results. All right, you guys got me some data earlier to make a confidence interval. So let's make a confidence interval. So what we're really going to do is let's estimate with, how confident do we want to be? Why don't we be 98% confident? Yeah. So let's estimate with 98% confidence the average number of cell phone calls for a student at Aragon. We better make that juniors and seniors. Do we have any sophomores in here? You're a sophomore? Okay. Kind of tall for a sophomore. Okay. All right. All right, so here we go. We have some data. We got a sample mean of 5.88. And we don't have a population standard deviation. So I'm just going to fudge and call it 4. And just to kind of round there. So we're making that up. And how big is our sample size? Is it 25 or 26? Is it 25? Okay. All right. So step 1, and it is okay to number the steps as you do them. Let's name the population and the parameter. The population is 11th and 12th grade students at Aragon. What's the parameter? Average number of cell phone calls in the last 24 hours. Sorry, I forgot to put that. All right. So step number 1, make sure you summarize what you're going to do. We are estimating the average parameter number of cell phone calls for Aragon. Yeah, 11th and 12th graders in the last 24 hours. Okay. So you'll get a problem, and basically you're trying to restate some things out of the problem. Some of these problems might be 2 or 3 paragraphs long. You gotta figure out what population we're measuring and what parameter we're measuring. Remember, parameters will be either some kind of a mean or average or a proportion. And we'll get to slope and correlation a little at the end of the term. But those would be the basic ones you'll be looking at so far. All right, step 2 is to name your procedure. So we are doing, this is procedure number 1 of I think either 16 or 18 that you will learn in the next few months. So there's a lot of similarities, but then you got to remember the differences. So we are making a 90% confidence interval, 98% confidence interval, for a population mean we're going to use a normal distribution. Because you don't know any other distributions yet to use, but we will soon. Okay? Number 2 is also about checking conditions. First condition to check is, did we do a simple random sample? So we didn't do a simple random sample. We just asked everybody in this class. If you don't meet conditions, you get to stop here. But you need to learn the procedure, so let's say that our sample was as good as a simple random sample. Yeah, some way justify simple random sample. And you don't justify with a check mark, you justify in words. So our sample was as good as an SRS. We're a pretty random group. All right. Condition number 2 is the sampling distribution needs to be approximately normal. Normality of sampling distribution. How can I prove that I have a approximately normal sampling distribution? Oh, so our sample size was a little small. Let's say we know the population distribution is normal. All right. So, I'll say we made this up. We'll proceed with caution. So we'll get there. Yeah. Okay. And number 3, independence. Well, is the population of Aragon bigger than 25 times 10? Oh, okay. Oh, that's the population of juniors and seniors greater than 250. Yeah. So, but we didn't have a simple random sample, so we probably don't have independence anyway, but we are proceeding anyway because we want to do the problem. Okay. All right. Step 3. If we have passed all of our conditions, which we didn't really, but we are going to say we have, do the math. So our confidence interval is our mean plus or minus our critical z times our standard deviation divided by the square root of n. So we had 5.88 plus or minus, what's my critical z for 98% confidence? So the your table C, the T table says 2.326. We'll use that one. And we said the population standard deviation, we don't know that, but we think it's 4. Yeah, right. Divided by the square root, was it 25? Okay. Will you find that interval for me, please? Da 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 da.